Welcome to your online coffee break, where we discuss bite-sized topics that inspire, educate, and entertain. Here's your host, a software innovator, award-winning marketer, and astronomy and space buff, Chuck Fields.
Hello, thanks so much for joining me today. NASA's aircraft SOFIA, the Stratospheric Observatory for Infrared Astronomy, has confirmed for the first time water on the sunlit surface of the moon. Previously, NASA had discovered evidence for water in shadows of craters, but this new discovery has incredible implications for the possible use of water as a resource as NASA returns to the moon. Joining me today is Lunar Geologist Dr. Sarah Noble as she discusses this incredible discovery and its implications for the future of space exploration.
Online coffee break.
Thank you so much for joining me. Really appreciate it.
Great to be here.
We always love to talk to our guests about their space journey, where their passion for space began. I understand you're around 10 years old. You wanted to become an astronaut. Can you tell us just a little bit more about that? What inspired you there?
Yeah, I don't know. It was just one day it just popped into my head. Oh, maybe I could be an astronaut, and it just sort of stuck. I grew up in rural Minnesota. There was not a lot of space is pre-internet. I'm very old, and so there wasn't a lot of space and scientists and whatnot around me. But I was fascinated by space. I started to climb onto anything I could find about space, anything I could read about space. Managed to go to space camp when I was a teenager, and that sort of really cemented a lot of things for me. So,
now, Sarah, I love how you had sort of a personal experience with the moon when you were a graduate student. Can you tell us a little bit more about that?
Sure. I was working late in the lab one night, working on some lunar samples, some lunar soils, and I was walking home from the lab, and it was a full moon, and the moon was shining down. I looked down at my hands, and they were sort of sparkly, and a few grains of lunar soil sparkling on my hands, and I looked at my hands and up at the moon, and this dirt came from there, and I had this epiphany about the moon as this geologic place that's not just up in the sky, but it's a place with rocks and dirt and a place we've been and can go back to, and it was just a real moment.
Now that had to be surreal with the recent announcement this week of the discovery of water on the sunlit areas of the moon. That had to mean a lot to you. I'd like to get into a little bit more. I understand that was made possible by SOFIA. And for our audience out there who doesn't know what SOFIA is, can you tell us a little bit more about that?
Yeah, SOFIA is an airborne observatory. We actually took a plane and ripped the side out of it and put a telescope in there, and we can go and fly up sort of above the atmosphere, much of the atmosphere, and use it as a telescope. The measurement that they took for this paper that came out this week is actually really incredible. They'd never tried to use SOFIA to look at the moon before. Yeah. It's really hard, right? If you've ever looked at the moon through a regular telescope in your backyard, right? It moves, right? Over the course of the evening, it moves pretty quickly, right? And it, compared to most of the things that SOFIA is looking at, which are, very distant galaxies and whatnot, right? It moves to the sky. And remember, SOFIA is also moving too, right? It's a plane.
Yes.
And managing to coordinate all of that movement and still train your focus on that very small part of the moon is actually quite an achievement. And they've never tried it before. So, this graduate student at the time, Casey, the lead author of the paper, was like, well, can't we do this? And she put in an application to get some time on the telescope. They actually rejected it the first time.
Really?
She tried again, and the director of SOFIA was like, well, let's try this. We may as well give it a try, and gave her some of what's called director's discretionary time. It's a little bit of extra time that the director gets to, sort of make their own decisions about things. And so they thought, well, we'll do it. We'll do this test. And that's the results that came out this week was just that test. Now, they only did this one test, right? They'll be doing follow-ups now to sort of look at more of the moon now that we know that we can do that measurement.
What an incredible accomplishment. Now obviously, before we've discovered, we believe water ice is at the south surface of the moon. But this discovery is saying it's sunlit area. It's Clavius, which is a crater visible to all of us when the moon is visible at that particular phase. But I understand that they found basically the equivalent of a 12-ounce bottle of water in sort of a cubic meter. So roughly 30 square feet, you get a bottle of water. Not much, but it's still an amount. Can you tell us just a bit more about that?
Yeah, it's a very tiny amount. And to be clear, the measurement they're looking at actually only looks at the very uppermost surface, right? So they're not seeing down a meter. They're guessing
Good
about,
point.
well, if there's this much at the surface, we think there might be this much deeper down. But really, the measurement is only measuring the very surface skin of the moon, and it is a very tiny amount. So, people talk about it being used as a resource, and I personally think that it'll be very difficult to get that kind of water out. I mean, it is literally 100 times drier than the driest deserts here on Earth, right? So it's a very tiny amount of water. But doesn't mean it isn't useful, right? It tells us about water, about how water is being formed and moved around on the moon, and that can help us identify where the water resources are and understand how the water works on the moon, and that will help us evaluate resources.
Something that's incredible. Now, the other thing I heard too is that other spacecraft have hinted that there was water on the moon, or possibly not H2O, but hydroxyl. And can you just tell what is hydroxyl?
So hydroxyl is OH as opposed to water is H2O. And a lot of our previous measurements from orbit at the moon has sort of looked in the 3 micron part of the wavelength, right, where there's a band that is sort of overlapping, where OH and water both have bands. This measurement, SOFIA, looks out at longer. It looks out at 6 microns, 6.1 microns, where there's a band that is only due to water. There isn't an OH band there. And so we can say definitively now that the bands that the hints that we had seen earlier of OH and water, and there's probably both there, OH and water, but we couldn't untangle them. But we can say definitively now from these SOFIA measurements that it is in fact H2O and not just OH.
What are the current theories going on for how on Earth, or how on the moon, I should say, water's on the moon? How did it get there? Any ideas?
Yeah, so there's a couple of ways that we can do it. So first of all, the sun, the solar wind is constantly supplying hydrogen to the moon, right? Solar wind brings hydrogen to the moon. The rocks of the moon themselves are about 40% oxygen. And so there are ways that you can sort of bring this hydrogen in and combine it with the oxygen, particularly when you get micrometeorites coming in and they generate a lot of heat and energy. And so you can find ways to combine the oxygen and the hydrogen. The micrometeorites as well also bring in water themselves, right? They are hydrated, some of them, and so they are also bringing in water. We don't know where that water is going and how easily it is captured and lost. There's also, larger meteorites, comets that occasionally hit the moon, and we think that water can sort of bounce around and maybe find it a place to get trapped. And then there's the original water that the moon probably had at some level back in its early history, right? So when there were 3 billion years ago, when there were still volcanoes active on the moon, that was probably bringing some amount of water and volatiles up as well.
Now, as a lunar geologist, I guess personally, what excites you the most about this particular discovery?
I think it's great. I look back at, my career when I started studying the moon, we thought the moon was completely dry. No water on the moon. That's ridiculous. The moon is completely dry. The way that it was formed, this hot impact with when the Earth was impacted by this large Mars-sized object and it generated the moon, and it was hot and violent, and all that water was lost. And the moon is completely dry. There's no water on the moon. That's ridiculous. And then over the course of my career, we've I don't know how many times now we have found water on the moon. Over and over again, we keep finding that the moon is this much more geologically active place than we had assumed. And so I think as the story is still unraveling and we are learning more and more about the water cycle on the moon, the fact that I'm talking about a water cycle on the moon, past me would be just incredulous that I would sit here and talk about a water cycle on the moon. But I think it's great that we keep getting these little hints and pieces of how this puzzle fits together. And I'm excited. The next few years are going to be a really exciting time at NASA for the lunar scientists, right? We are sending a lot of stuff towards the moon. And a lot of it is focused on understanding this water cycle. So we've got some commercial landers that are going to land some instruments near the poles fairly soon. And then there's the Viper rover, which I'm the program scientist for the Viper rover, the Volatiles Investigating Polar Exploration rover, which is very specifically designed to sort of explore some of these regions at the poles where we think that there's a lot of water. And to understand those resources, it's got to drill. We can drill down and see how the water is distributed at depth.
Wow.
So that's really exciting. And then, of course, the Artemis program, we're going to send humans. Humans are fantastic geologists and will help us bring back some of those samples so we can really dig down and understand these cycles.
That's incredible. What is the timeline for Viper?
Let's see. So Viper is to launch in 2020. I should know this. It's my mission. 2023.
Things change so constantly in this. But it is coming. So I was going to ask you, like, what is next? So I mean, it's just exciting. I didn't realize that Viper was coming in the next couple of years. And you're right, with the Artemis returning the first woman and the next man to the moon. I think that's going to be incredible in that. I do want to ask you though. You're an incredible artist, and I had come across some of your beautiful space art. I just want to tell us a little bit more about your space art. What inspired you to not only be geologist, but also be an incredible artist?
Yeah, it's funny. People always ask, "Oh, you're a scientist and an artist?" Like, I don't understand, and I always think that's really funny because, right, they're both the same thing. They're both creative problem solving, right? And in fact, there are a lot of us, if you look around, science that are also artists and musicians and poets, and I think we all need to use both sides of our brains, and it's a great outlet. But for me, I just feel like the moon and space is just such an incredibly beautiful place, and I'm much better with paint than I am with words, and so I
understand.
I just like to express that and show the world how gorgeous the solar system is.
Oh, it is beautiful, and your artwork is amazing. Just one last thing, too. A lot of people out there are very inspired when maybe they have kids that are expressing interest in space. Maybe they're 10 years old, they want to become an astronaut. What advice would you give the kids or the parents out there of those kids?
Yeah, you know what? It is an exciting time for NASA. We are looking to go back to the moon and to Mars and to start exploring more of the solar system. And I think my advice for any kid is to follow the things you're passionate about. Right? There's room at NASA for everybody. We have scientists, we have engineers, but we also have budget people, and we have artists, and we have communications experts, and there is literally a job for everybody at NASA. And so if you want to be part of this adventure, follow your passions and join us in whatever way your talents provide.
Oh, wonderful. Sarah, again, this has been a pleasure. Thank you so much for taking time today to tell us about this incredible discovery. Congratulations and thank you.
Thank you.
Online coffee break.
Wow, what an incredible discovery of NASA. Next time you look at the moon at night, you can look up and actually see that the moon is no longer just a dry, barren, dead surface. It actually has water. Now, of course, not puddles or lakes, but again, the possibility of extracting water for future space missions. For me personally, I think that's incredible. If you'd like to learn more, just go to nasa.gov/SOFIA. That's SOFIA. I want to thank Sarah for joining me today to discuss this incredible discovery. I want to thank you for joining us as well. Again, we'd love it if you just share this episode with a friend. Also, if you can give us a like or a thumbs up if you're watching YouTube, we'd appreciate that too. Thanks so much for joining us. We'll see you next time. God bless.